So your warm-up was really just a review. A lot of that came from your test, things that caused issues on the test. Please understand that you will be seeing these things again and again and again, which is why we put it in the warm-up here. One of the toughest things that you guys have been facing in this class is remembering things that you were supposed to have learned before. You have to understand that in math, in life, you don't just learn a lesson once and then ignore it. You have to keep these things. You have to keep them accessible. These are your tools for everything else. Okay? And a lot of you guys are seeing that when it comes to the fractions. You're not comfortable with your fractions. It's showing up, and that was a lesson back from 4th grade. Okay, so these aren't new to you, but you have to remember them. So if you're looking at, zoom in here on problem number 1 first. Take a look at 1 and 3. They're both there. Okay, this could very well be the review portion on your next test. Could you do this? Questions on number 1. You had an angle side pair. You could use law of sines. When you find your height, you learn that the height is 7.3. And your opposite is bigger than your height. Your opposite is also bigger than your adjacent, so you only have one triangle possible. And since we're looking at that side, always factor your BCF out first. Then that becomes a difference of cubes. Okay? Many of you all were doing very well with this when we were in the unit. You got your graphs, and then we moved on to the next unit, and you forgot your graphs. So this problem is going to start up 3. That's the first dot I drew, was that right there. 1/4 tells me the width. Negative means I go backwards. Inside you do the opposite. So opposite of 1/4 is a width of 4. One negative sign, no matter what, you're going to go downhill. So that means that from here, I go down. Here, I go down. So on and so forth. Okay? Questions? It's a Friday before a long weekend and a short week. You guys should be happy. Okay? And one of the main things that jumped out to me while I was checking your homework. If I ask for the 6 trig functions, you must put the angle that you're looking at in there. It is never just sine equals 1/2. Your sign changes depending upon what your angle is. You have to have that angle there. That is a requirement. You leave that off, you're leaving off serious points. Yes. If you tell me theta equals 5 pi over 6 someplace, okay. But you have to define it because we use theta when we don't know what the angle is, when we're solving for an angle. Okay? So in this case, I know what my angle is. Please put it there. Do not write the reference angle in that because that will actually have different answers. The cosine of pi over 6 is positive root 3 over 2. So you have to be careful about what you put in each of these places. Questions on number 4? I'm going to jump right to the heart of the matter with your homework. People coming to me with questions. Okay? So you need to understand that when we are talking about a unit circle, or any circle, you cannot see that at all, we measure our angles starting on the x-axis going that way. What would it mean if I gave you a negative angle? It goes what? Yeah, a negative angle is going to start here and go that way. If you don't feel comfortable dealing with negative angles, remember from that very first, I didn't see a copy of it, very first homework that you had, it had coterminal angles, angles that had the same ending point. If you don't like this, what you can do is you can always add a circle to it. So starting here, add 360 and see what that next point gives you. So if you have an angle that is not either between 0 and 2 pi or 0 and 360, if it's not between there, then add or subtract 360 degrees or 2 pi until it is. Okay, very, very simple concept. We have to be putting things together as we move from one idea to the next. And even in your homework, because there are a lot of people who are like, I don't understand this. They're giving me negative numbers in the homework. What do I do? Well, if you're stuck with something, you can always go back and actually look at the textbook and see what they did. Okay, that's the reason why we have textbooks, is to provide you with additional sources of information. Okay? So, with that being said, homework questions. Let's start with the homework questions on page 367. Homework questions from page 367. Those were converting angles from radians to degrees and degrees to radians. And hopefully at home you're doing these without calculators. Yes? 44. Okay. 44 gives me negative 225 degrees. There are several ways that I'm okay with this. You want to leave it like that and convert? Fine. The rules don't change. All you need to do, I want the degree to go away, so I'm going to times by pi over 180. And then we're just going to see what we get. So I see that this one here ends in a 5. That ends in a 0. So I know 5 goes into both of them. 5 goes into 225 how many times? 25. 45? 45. Okay? 5 goes into 180. 56? I was going to say 56 is a little bit big. 36. So that means that I'm now to the point where I have negative 45 pi over 36. Does that simplify it all? It does. What number goes into both of those? 9 goes into 45 how many times? And into 36? 4. So you can use that as your answer. It is also perfectly well and good. You have a negative answer or negative problem, add 360 to that to get what the positive would be. So 225 negative plus 360 would give you what? 135. And you can use 135 and then change your answer. So again, 5 goes into that. 5 goes into 13 twice. 1 left over, 23 degrees. 5 goes into this, 36. And so that's going to be 23 pi over 36. And I did that wrong. 5 goes, that's not 23. That's 27. Thank you. No. 20, yeah, it is 27. Okay. And then I have a number that goes into both of those. 9 again. So I can do 3 pi over 4. Both of those are equivalent answers. I don't care which one you give me. Really, I don't. They're the exact same thing. This has a nice benefit because you're going to have a smaller number. You're not going to have negatives. This one has a benefit. It's one less step. They're both equally good. Okay, other questions on 367? Yes. $50 is similar. 50 says negative 2 pi over 3. We're converting radians 2 degrees. I want the pi to go away, so it goes on the bottom. The 180 goes on the top. I'm not even worrying about the negative. I'm not letting it bother me. 3 goes into 180 how many times? 6. Negative 2 times 6? I'm sorry, that's 60, not 6. Negative 2 times 60? Negative 120. Done. That's it. The rules don't change because there's a negative involved. But again, you don't like the negative? Add 2 pi. Add a full circle. So that is going to give me, so that's 6 minus 2 is 4 pi over 3. And then you do the same thing. 180 over pi. That's still 60. And I would have 240 degrees. I don't care. They're both good. They're the exact same thing. One's just been spinning around the circle in a different way than the other. Opposite disease. That sounds like disease. Opposite dizziness. Okay. All right. The 384 page. One more time. 54. So 54 is 11 pi over 4. You don't like it? Make it between 0 and 360, or 0 and 2 pi for this case. So 2 pi in terms of fourths is what? 8 pi over 4. So that's the same thing as 3 pi over 4. So you can just use that. So if I use 3 pi over 4, what quadrant is that in? It's in the second quadrant. So it's negative, positive. And I love the reference angles of pi over 4 because it's always root 2 over 2. And please, 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 when you write these out, write out the sign. I don't care if you write 11 pi over 4 or 3 pi over 4. But you need to write the sign of 11 pi over 4. Sine is y. Cosine is x. Tangent. I hate 11 pi's. They're so hard for me to write. Is y over x, so it's negative 1. Then your cosecant. See, did it again. I hate that. Is reciprocal, so that's just root 2. Secant. Reciprocal, negative root 2. Cotangent. Reciprocal, negative 1. How much is 8 pi over 4? That's 2 pi. What is 2 pi? It's a full circle. 11 pi over 4 is not in my standard circle, which goes from 0 to 2 pi. So just like we did before, add or subtract a circle until you get within your normal circle. So I subtracted a circle to get something I'm more familiar with. Okay? Yes? Same idea. 60 gives you negative pi over 3. That's not in my circle. What do? Add 3, well, not 360. 2 pi. And 2 pi is 6 pi over 3. So that was a negative. So I end up with 5 pi over 3. So I'm just going to do that angle. You could do negative pi over 3 if you know where that is in the fourth quadrant. I like 5 pi over 3 better. So 5 pi over 3 is in the fourth quadrant. So it's positive, negative. And in the fourth quadrant for root 3, that's going to be 1/2 root 3 over 2. Correct? Okay. And so then we would just walk through it. Are you okay with sine, cosine, tangent, secant, cosecant, the rest of them, as long as you have that point? Okay. Yes. Don't switch back and forth from radians, degrees to back to radians. Don't do it. You are adding steps that you don't need. And in adding steps, you're adding opportunities for mistakes. Okay? So we're going to be going back and forth between radians and degrees for the whole time. You just need to understand the denominator is 3. That means the angle is 60. The denominator is 6. The angle is 30. The denominator is 4. The angle is 45. You need to be familiar with that. You do not want to be going back and forth. It is going to make your life a heck of a lot harder. There are going to be many times where dealing with the radians is actually easier. Okay? Yes? No? Tangent is y over x. Negative over positive is a negative. Cosine would be positive because cosine is the x. Okay? All right. Go ahead and clear your desks for me. Thought you'd like that. My attempt at being funny. Define the following. Trigonometry. He sits, he stares. It's a weapon of math destruction. That's what trigonometry is. Not funny? No? I thought it was. That kind of looks scary, doesn't it? Stuff just got real. Stuff. Not the other word. Stuff. It's okay. Because, believe it or not, I'm not really teaching you anything new today. I'm just tweaking what we've already gone over and over and over again. So, you don't have this printed out because you don't need to write a whole ton of stuff down. Actually, you might not need to write anything down because I believe we wrote it down last class. All I'm going to go over here is we have our quadrants. And first quadrant, all of my coordinate points were what? Positive, positive. Second quadrant, negative, positive. Third quadrant, negative, negative. Fourth quadrant. Okay. We also talked about all students take calculus, which is another way to remember this. Hopefully so far, not a single thing new. And then the last thing that I did is I said, hey, we can draw a triangle. Think about it in terms of my reference angle. And if I have a coordinate point x, comma, y, this is my x, this is my y, and in the general term, and we're dealing with the general term here today, just not the unit circle, this is my radius. It's just that on the unit circle, the radius is 1. So using this triangle, what is the sine of my angle? Y over r. Not new. What is my cosine? Not new. What is my tangent? Okay, y over x. And lovely, 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 our reciprocals are just the reciprocals. R over x and x over y. Okay, I lied. There's one thing I didn't tell you last class. If I give you x and I give you y, how do you find r? Oh, so you knew that already. No, in the unit circle, r is 1. Generally speaking, you can do Pythagorean theorem. Okay, so maybe you do know everything. That is all. Look at this. No notes, just problems. That's it. We know everything. Yes. Always. Because that's the only way this works. SOHCAHTOA, you might have your law of sines, law of cosines. Those might work in all triangles, but the sine, cosine, tangent is all about right triangle ratios. Okay? Yes. Absolutely. Have I changed a single thing? Nope. Everyone's going, yes, yes, you have to. You can't do this. Okay? It's still the same thing. It's all right. The only thing that's any different is I'm not on the unit circle. See, I don't recall seeing 3, 4 on my unit circle anywhere. That's okay. It still works. I can still find sine, cosine, tangent, and all of the others of this one angle. It's almost easier because we don't have to memorize anything. When I look at this is my x, this is my y. How do I find my radius? Pythagorean theorem. Am I blowing your minds yet? So to find the radius, I will say 3 squared plus 4 squared equals r squared. And you know what? A lot of you don't even need to do the work for that. What is r? R is 5. You do need to know, no matter what, radius is just a measure of distance. Radius is always going to be positive. Always and forever. So these numbers will be negative or positive, but the radius is always positive. Yes? Sine of theta, because it says we don't know what the angle is, so we're just going to write what their ratios are. So we would say sine of theta, cosine, tangent, and then I would do, every pair has a co, so cosecant, secant, and cotangent. I'll tell you right now, the nastiest this gets is radicals, square roots, just like the nastiest any Pythagorean theorem problem gets. Okay, so using what I have up here, what is your sine? 4 over 5. Boom. That was nice and easy. What is your cosine? 3 over 5. What is your tangent? Any questions where those came from? All right, then. What is the cosecant? 5 over 4. Secant? 5 over 3. Cotangent? Mic drop. Or pen drop, or whatever. Mic's attached to my head. I'm not dropping it. Smack my head on the table. What do you think? The only way I make this icky, seriously, the only way I make this icky is with not nice triangles. Things that are going to have square roots. Woo! Spooky in time for Halloween, but that's it. If you look at number 2, this is why you didn't get printed out notes today. They're just coordinates. It's not that hard to write down. Number 2, this is my x. This is my y. Can anybody tell me what my r is going to be? Oh my gosh, how'd you do that? It's amazing. That's another one of your Pythagorean triples. 3, 4, 5, 5, 12, 13. Please don't forget those. They pop up again and again and again. So this comes from saying, and even if we have a negative 5 squared, a negative 12 squared, when we square those, they still become positive. And your radius is always positive. Now we just do what we got to do. I want you all to find your sine, cosine, all of these guys. Please notice, I'm still writing an angle in there. It's not sine by itself. Would like you guys to write all them out. Can you handle the math of today? How are we feeling? Like, whatever, right? You're not like super excited that this kind of falls in line with what we've been doing? There's got to be another. Where's the but? You're sitting on it. That was really lame. Sorry. It's Friday. I don't want to be here any more than you guys do, so I'm going to fake it until I make it. What? Thanks for making me feel stupid. Gosh. What do you think? I'm perfect? I never claim to be perfect. Yes, it's 5/12. I'm a dork. Okay? That's the big idea. I can make this ugly. Watch. Aiden's like, I knew you would. Look, this is how I make it ugly. It's not a Pythagorean triple. Can you handle the math? I want you all to tell me. I'll just say it. Find it. Find the radius. This is how I make a problem ugly. And unfortunately, if I make this ugly, it's going to make the sines, cosines, tangents, all that other jazz not quite too pretty either. Trig with a bedhead. That's what this is. What'd you get for the radius? Oh, wow. You guys are amazing. You can do the Pythagorean theorem. Yay! Okay. Yeah, this part, I know, this part's not so nice. Okay. You've got radicals. You can do this. When I do the sine is what over what? Y over R. So 2 over the square root of 5. You do need to rationalize that. Look at you go. See, you've got this. 2 root 5 over 5. This is how I make it ugly. This is it. Cosine is going to be what over what? Look at you guys. You're skipping straight to the answer. Negative root 5 over 5. By the way, I'm chuckling to myself. If my high school math teacher saw me doing this, she'd scream. She hated it when you did the fraction bars like that. She'd just go nuts. She'd be like, I'm taking all of your points. I'm like, whatever. I don't know. She just, like, I'm seriously, my whole head right now is just going, my teacher would have been so ticked off. Hey, got an idea. So for tangent, what am I going to do for tangent here? Do you really need to put it over 1? Let's just write -2. You okay with that? You don't really need to write over 1. I mean, but we've been simplifying it for the next step. So if you want to write negative or 2 over -1, that's fine. It's just -2. The reason why I like to start with this, no matter what, is because it's either going to be my original function or my original ratio or my reciprocal ratios. One of them are going to be ugly. And it's a lot easier to do the reciprocal of these original pieces than it is to do the reciprocal of these. Do you understand what I'm saying? It's a lot less work to just think, oh, I'm going to flip this. So then the cosecant would become √5/2. So you can see here, this to me is a lot more work because you'd have to do the reciprocal, rationalize, simplify. But if you're going with that guy, it's a lot easier. What would your secant be? -√5. What would your cotangent be? -1/2. With that being said, I want you guys to do number 4, all the way through, start to finish. Check your answers with your neighbors when you're done. Compare these guys out. It's the radicals that really are the most troubling, the most irritating. Bless you. Can I pull up the answers? You guys think you got it? Almost? Okay. Just throw your pens around, see if anybody cares. Just kidding. All right, here are your answers. Did you simplify sine, cosine, and tangent? Did I do something wrong? I can't hear over everybody else. Did which one? Did Stop judging me. Didn't you know that 16 plus 36 is 50? Can't you see? Gosh, how'd you not know that? You're so judgy. Meanies. All right, so let's see here. 16 plus 32 happens to be what? 60. Oh, my Lord! Is 52. Now, 4 goes into 52, so that's 2√13, which I would have known if I was actually thinking. So, line is going to be, that's going to be over 2√13. It would be 2√13. Ah! So that means I'm going to have -3√13/13. Is that okay? Please tell me I'm right. 2√13/13. Gug. This is going to be so that means I'm going to have -√13/3 and √13/2. Is that okay? okay. I'm so sorry. I know how to add, really. I do. Because the 2 root 13 over 4, 2 over 4 simplifies to 1/2. Flip-flop. 2 root 13 over 4. 2 over 4 is 1/2. And this is the only kind of like other things I can make you kind of do with this. What do you think I'm going to do with this? I'm going to find the y. How am I going to find the y? Pythagorean theorem. So I have 4 squared plus y squared is r squared. So that means I have 16 plus y squared is 144. That tells me y squared is going to be equal to what? What is 144 minus 16? Apparently I can't do math, so I need your help. We in agreement? Yup. And then when I take the square root of that, let's see here. 4 is a perfect square. 4 goes in 32 times, but 4 goes into that also. 4 goes into 32 8 times. Hey, wait a minute. Isn't this just 2 times 64? And what's the square root of 64? So this is 8 square roots of 2. That means I have the coordinate point 4, 8 root 2. I have the radius is 12. Why would they tell me Q1? That means that this guy's positive. So for example, in this one, when I say Q3, what is that going to tell me about this? X is going to be negative for this. No, you still will have to do the 6 ratios. We're just running out of time. So what we're going to do, I want you guys take this, and I want you right now, I want you go through, and I want you to find my 6 ratios for that.